All right, welcome to the screencast for Honors Chem. The Unit 2 we're going to get ready to get started on is about scientific measurement. So I'm just going to go ahead and switch slides. So this is going to be objective number 1, distinguish between quantitative and qualitative measurements. We're also going to talk about accuracy and precision, so some basic vocab terms in this objective. Quantitative, if you look at the root word, it's quantity. Results are in a definite form, meaning they have numbers with them. So numbers or amounts. Example, 65 rulers, 32.4 milliliters. If I take your temperature and your temperature is 102 degrees Fahrenheit, that is a quantitative measurement. Quantity. Think numbers. Qualitative measurements, the root word is quality. So think words. Descriptive forms or words. These are non-numeric descriptions. So if you're running a fever that's 102 degrees, that's a quantitative measurement, but you might look hot or you might look red or feel hot, and that's going to be a qualitative measurement. So the beaker looks hot or the person looks red. In class, we're going to watch this video clip, so you do not need to watch it right now. We will watch it in class. So that concludes quantitative versus qualitative. Our next two terms, accuracy versus precision, we're going to spend a little bit more time talking about. Accuracy is how close a measurement comes to the actual value. It's how close you are to the correct answer. So if somebody is 6 foot tall and I guess that they're 5'2", I'm not very accurate because I'm not close to that actual value or the correct answer. It depends on the person. So for example, if you're guessing weight or guessing height, it just depends on the individual person. If your goal is to get an A on a test and you get a C, that's not very accurate. It's how close you get to the expected outcome. Precision, on the other hand, is the reproducibility of a measurement. So it's how close your measurements are to each other. When we talk about significant figures, you're going to see that significant figures are a big part of precision. They show how precise a measurement is or how precise a number is. Precision a lot of times depends on the quality of your instruments. The better instruments you have, the better instrumentation you have, the more decimal places you can go to in a measurement. So the more precise, the more detailed your measurement is going to be. For precision, a lot of times what you'll see is we do something 3 times. You take a mass 3 times. And all 3 times, those should be very close to each other. They might not be exact, but they should be very close to each other. If they are close to each other, that shows that there is some precision there. So it's the reproducibility of a measurement. For example, my goal might be to get an A on a test. But if I get a C on the first test, a B on the second one, and a C on the third one, I'm pretty precise, but I'm not accurate. So if the numbers or measurements are close to each other, that's precision. If they're close to the actual true value, that's also accuracy. So we're going to watch this video in class, and we're also going to discuss darts as well as the grades on test, which I just gave you that example. But we're going to go through an example with darts in class. So we'll watch the video, go through the darts, so leave some space in your notes for this material. So the next part of this, there's just a little blurb I want to talk about using the metric system. In science, we use the metric system. We do not use the English system. It's base 10, so the nice thing is you just multiply or divide by 10 to move to different units. You don't have to remember that there's 12 inches in a foot. All you have to do is be able to multiply or divide by 10 to go from millimeters to centimeters. It is used worldwide except for the US, Liberia, and Burma. There's decimals only. There's no fractions. That's what makes it nice compared to the English system where we see fractions. So we use the metric system. When you are taking a measurement, you should put a 0 first, a 0 before the decimal point. So if you have a decimal point where something is less than 1, make sure you put a 0. Always indicate or always include the units. So whether you're measuring something in milliliters or centimeters or grams or kilograms, whatever you're measuring it in, make sure you include the units. And then we're always going to estimate the last digit. So you can always go 1 digit further than what is marked on your device. And I'm going to show you an example of that. So we're going to watch this video also in class before we do our measurement activity. So here's some practice with estimating the length and estimating that last digit. You can clearly see that this is definitely 1 centimeter, but it is not 2 centimeters. And not quite being 2 centimeters, you're not going to say that this is exactly 1, because it's obviously a little bit more than that. So we can now estimate, or we can go to the tenths place. So is it 1.1? Is it 1.2? Is it 1.3? Is it 1.4? 1.5? And you can see that it's somewhere in between 1.1 and 1.2. You might argue that it is exactly 1.2, and that's fine. You would just have to then say that it's 1.20. You can estimate that last digit. So divide this up, this distance in between 1.1 and 1.2 into tens, and then estimate where that dice falls. And this might be 1.20. You might even say that it's 1.21 or 1.99. You could argue that by getting as precise as possible, but you can see that those measurements are pretty close together. So I want you to do the same thing for these next slides. I'm going to show you the pictures, and you can pause this as needed as you go from slide to slide. So on this marker, I want you to determine the length in centimeters. Okay, on this, this is a graduated cylinder. Do not look down from above. You don't want to look from below. This is looking down, not straight at it. This is looking from below. This is looking up at it. The correct way to measure a liquid would be to look right at it straight on. So you want to make sure that you are parallel with it, so that way you can see the proper form of the meniscus to take your measurement. And go ahead and take down what this measurement is. So here, this line here means 80. That line here means 85. So this would be 86. And you might say it's 87.0 exactly, because it's right on that line. Go ahead and take this measurement. This is for mass, looking at a scale, so it's going to be 4 grams. And then we are into the tenths place, so 4.3. We're not quite at 0.4, so 0.3, this would be 0.31, 0.32, 0.33, 0.34, 0.35, 0.36, 0.37, 0.38. And then we look at this, we're in between 0.38 and 0.39. So you can't say that it's exactly 0.38 or exactly 0.39. You have to estimate that last digit. So maybe it is 4.3 and then 8, and maybe estimate 8. So 4.388. So go ahead and write down those measurements. This is the type of stuff we're going to do in class for practice. Go ahead and take this measurement down. This is showing that it is at the 2, but this is also sitting at 0, so it's just showing you that it is 2 and then 0.3, and go ahead and take down that estimate, or that measurement. I'll let you take down this measurement right here. This is showing that you're at 20 and then at 1, and you have to add all these together, so we're at 21, and then you figure out what your decimal points are going to be. I'll let you take that measurement, and we're going to go over these in class. Same thing here. I want you to take this measurement of the graduated cylinder. This is a picture of it straight on so that you can see. Remember to measure from the bottom of the meniscus. You don't measure the top or the middle. You measure right at the bottom. So go ahead and record how many milliliters that is. Again, record how many milliliters this is, measuring from the bottom of the meniscus. Remember, you can pause as needed. Okay, so in class today, what we're going to do is watch those video clips. We're going to go over these examples that I had you take the measurements for. You guys are going to do a paper clip activity. We're going to do a reading graduated cylinders activity. And then if there's time, we're going to do a lab on accuracy of measurements. We'll probably end up doing that next class. There will be a handout that I will give you on accuracy and precision that you will do. And the summary for this objective is a 3-2-1 format.